Hello, geometry, and welcome to the beginning of the end. This is the first section of our last chapter, which is going to be about area, surface area, volume. We're going to start off looking about area and perimeter with a circle. So we're going to first talk about the circumference of a circle. Circumference is like perimeter. It's the distance around. So it will be one-dimensional. And we know that there are two radii in one diameter. One thing you might not have known, we tend to do a little investigation of this to show that it is always true, that if you find the circumference, the distance around of any size circle, and you divide that by the diameter of that same circle, you will always get this constant, and we call that constant pi. That's where pi comes from. So notice that if I cross multiply, I get the circumference is pi times diameter. And since we know there are two radii in every diameter, you can also write this as 2 pi r. They both are equivalent. It all depends on what information comes to you. And now on your calculator, you should notice some people have a pi key on their calculator. Otherwise, you might want to use either 3.14 or the fraction 22/7. Both of those will be good approximations if you don't have a pi. But most of the time, we'd like you to leave pi in your final answer. Okay, so let's do an example. Find the circumference of a circle with a radius of 9 centimeters. All right, so I'm going to use the formula that has the radius. So this is going to be 2 pi times 9. Which will be 18 pi, and our units will be centimeters. Then this next one, find the radius. Now we want to find the radius of a circle with a circumference of 26. No pi on that. So we know that the circumference is 26, and we set that equal to our 2 pi r, and we want to solve for r. So I'm going to divide both sides by 2 pi. And when we simplify that, 2 goes into 26 13 times. And here's a case where you do want to probably go to your calculator. 13 divided by pi, or 3.14, is about 4.14, and our units were meters. So there's an example where you might want to get a decimal answer. Okay? All right. This next example is about arc length. That's not an example, next concept. So arc length is if I'm just looking for not the whole circumference, but just a fraction of the circumference, which is exactly what arc length is. Arc length is just a fraction of the circumference. All right, so a little bit of a review before we get started on this. Remember that the central angle in a circle is the same as the intercepted arc. So we know that the measure of arc AB is also going to equal x. Now let me give you kind of an example that might help make sense here of what we're doing. If I had a circle and I wanted to find, let me use a different color, the arc length of the top half of the circle. So I cut it in half. I know that the arc length would equal half my circumference. And if I had taken like a, looked at a right angle, then it would be 1/4 of my circumference. So how do you find that fraction? Well, the arc length is going to equal whatever x is out of the whole, which is 360, times 2 pi r, because 2 pi r is the whole circumference. So we can abbreviate this as x over 360 times the circumference. All right, well, let's do a couple examples. So down here we want to find the arc of AB, the arc length of AB. And we know that's the minor arc because they only use 2 letters. So we are going to set this up. We know that the arc length is going to equal, so the central angle is 150 out of 360 times 2 pi, and the radius is 18. So we're going to go ahead and simplify this. Right off the bat, I can make these zeros go away. So I have 15 out of 36 times 2 times 18 is 36 pi. So my 36's will cancel, and my arc length is going to be 15 pi, and my units are inches. All right, so that would be the arc length of that one. And now on this other one, we want to find the radius, so we don't know our radius, but we know that the central angle, or the arc, is 40 degrees, and we know the arc length that goes with that, right here, is 18 pi. All right, so let's set up our relationship. Arc length is, well, I'm going to just put it down generically. X out of 360 times 2 pi r. And r in this case is what we're trying to solve for. So let's plug in what we know. We know the arc length is 18 pi. We know x is 40 out of 360. And then we have our 2 pi. Okay, so I'm going to simplify things on one side before I start multiplying things to the other side to isolate. Whoops, didn't even write down my r. Silly me. Okay, so right off the bat, those zeros can go away. And I know that 4 goes into 36 9 times. Okay, so that fraction is completely simplified. So I have 2 pi r over 9 equals 18 pi. Now notice I have a pi on each side, so I can make my pi's go away. And let me rewrite this mess. I have 18 now equals 2/9 times my radius. So I'm going to multiply both sides by the reciprocal. And that's going to give me 2 again, goes into 18 9 times. You guys have calculators, so you can do this much faster in one step. I get that my radius is going to be 81, and I'm looking for any kind of units. We don't have any units, so that's going to be my final answer. There you go. There's your first lesson. So we have circumference and arc length.